So for our 5-number summary, for this particular data set, if we wish to plot these numbers, we could certainly just simply scale them evenly and get the information arranged so that it's scaled appropriately. Let's use the calculator to help us do the work. So if I go into my calculator and I have these values, the min, Q1, median, Q3, and the max, although I could plot them simply just by putting in the 5 points and then connecting the dots, what I'm going to do is in fact just go to graph and what we well, actually let's do statistical plots. So I'm going to go to statistical plots and then select a standard. So there are 2 different box plots. I'm going to select this one over here. 1, 2, 3, 4, 5. And when we plot that one by hitting graph, and let's make sure we're zoomed appropriately. So I'll say zoom 9, and you can see that the plot that we just put here looks very much like the plot that we would have done by hand. And we did this by simply taking those 5 points, the 15, the 17, the 22.5, and just plotting the 15, the 17, the 22.5, the 39, and the 101, using the left the endpoints rather, the left and right endpoints for the min and max, using these 3 to get your box, and using this one here in the middle to represent your median. So with that type of quick sketch, we can see that 20 or 50% of our data is actually less than about, well, we know what the value is. It was 22.5 for our median. We can also see that 50% of our data lies between, call it between 20 and 40. So box plots are really useful in that sense. It helps you get some information pretty quickly. But what does stand out is the possibility of there being an outlier. So an outlier are these unusual points that they may be so far beyond average that we may not want to include them as representative of the data set. There may be some unique characteristic about that particular outlier. So if these were gold medals earned by each country, but one country had 101, is there something about that country that made it unusual? Is it wealth? Is it a country from another planet, right? And so should we consider that as an average country, and are we really comparing apples to apples? So let's think about how we might handle these outliers. So what we're going to do is basically use this distance here, right? And whatever that number is, that Q3 minus Q1 value, that value, I'm going to take 50% of that. So let's go ahead and do it. Let's draw that here. So this is a so-called interquartile value. That is the Q3 minus Q1. It's that difference. So if I add it to Q3, I'm that far over. And so what I'm going to do is one more thing here. I'm going to add, not quite double it, but let's take half of that. So just 1 1/2 of the IQ of the interquartile range. So that's how that distance here is 1 plus 1/2, and we're adding it to whatever that Q3 value is. Anything beyond that point we're going to call an outlier. And so we're going to look at values here and find the first value that is within there. So what's the value that's less than 101 and that's not an outlier? It looks like it's probably going to be a 65. So that's the basic thinking behind some of this information that I'm going to give you right now. So let's go ahead and put in some space for us to work with. And let's define that a little bit more precisely. So anytime you have a box plot, right, we may have to find the outliers that are there. So the outlier, to find them, it's going to be required that we look at the box, we look at Q3 and Q1 and find that difference. Right? I won't be concerned so much about the whiskers on either end, but I'm concerned about Q3 minus Q1. So shorthand notation for Q3 minus Q1, we're going to call that our interquartile range, or the IQR, right? It's the range of values between the quartiles, the third quartile and the first quartile. So the interquartile range, let's see, Q1 was 17, Q3 was 39. So we had these two values of 17 and 39. So the IQR was just simply Q3, the one on the right, minus the one on the left, or 39 minus 17. The IQR should always be positive. So that's 22. So a distance of 22 plus 1/2 is what we're going to consider when looking at our original box plot. So values that are not outliers will be within this range here, where you have the left side, Q1 minus IQR times 1.5. So Q1 minus, and then the reach goes out 1.5 times the IQR. And then the reach out on the right side is Q3 plus 1.5 times the IQR. Now the IQR is 22. So what we're going to do is say that 1.5 times the IQR is going to be 1.5 times 22, 1.5 times 22. So basically I'm going to add half. You can multiply that out, but it's really just taking half of 22 and adding it to itself. So that's 22 plus 11, or 33. So the values that are not outliers are all of those values that sit in this Q1 minus 33 and Q3 plus 33, and those values are Q1 is 17 minus 33. So that's a negative 16. And then Q3, let's go to the right side, 39 plus 33. And so that's going to be a negative 16 and 72. Anything outside of that would be considered an outlier. So in this case, there is only one outlier in our data set. There's only one value that's not within that range. None of these values are less than negative 16, and only one value is actually greater than 72. And so that's going to be our 101. So there's only one outlier in this case, and that outlier was 101. Also, our calculator would have helped us find that outlier if we had decided to use for our statistical plot, instead of instead of 1, 2, 3, 4, 5, let's go back to this one over here. This one will actually help us observe the outliers. When I graph this one, and then where's trace here? Trace is right here. So if I hit trace, oops. So if I hit trace and step through, notice that it gives me the max of 101, and then it eliminates the outlier and finds the value, the first value in the data set that is within the interval of -16 to 72. So it lets you know, in fact, what that outlier is. And if I had multiple outliers, you would see multiple points that aren't tied in to the boundaries of the whiskers. So this modified box plot will give you, it'll point out what the outliers are. So we're going to call that a modified box plot, right? So if the box plot ignores outliers, we call it a modified box plot. So that's how we can handle outliers.